Laundry, a common practice you probably encounter several times a week. Yet, have you ever wondered how washing clothes actually works? Or washing anything in your home for that matter? There's chemistry involved in everything you do, a lot more than you would expect just to get that stain off your shirt. So, how do your daily cleansers work? One could say the first production of soap dates back 4,000 years ago when the Sumerian people blended potash and oils, traditional ingredients that have barely changed over time. But the key ingredient to these cleaning products is surface active agents, also known as surfactants. Now, if you didn't skip over 8.3 in the textbook, you might have a faint idea of what I'm referring to. Surfactants are compounds that have the ability to reduce the surface tension of a solvent because of their unique chemical makeup, the most common solvent being water. As we know, water has a high surface tension caused by the intermolecular forces between its molecules, creating a skin-like film on the surface. This tightness prevents the water from interacting with soap on its own, which is why surfactants are very important. When the cleaning agents such as detergents and soap dissolve into the water, it dissociates to form two ions. These are usually sodium cations and a long anion. The anions have a charged head and a long nonpolar hydrocarbon tail. This charged feature is called hydrophilic, or water-loving, whereas the nonpolar chain is called hydrophobic, or water-fearing. Let's say there's an oil stain on a shirt being washed. Oil is immiscible with water due to its nonpolarity. However, dissolved surfactants orient themselves so that their hydrophobic ends stick to the oil stain and surround it. As the water becomes attracted to the hydrophilic end of the surfactant, the soil material is suspended and protected by a barrier. These barriers are circular and are better known as micelles. After the stained surface becomes saturated with surfactant molecules, it is jostled and pulled from the surface. The grease becomes the center of micelle, a shape where the hydrophobic parts of the surfactant point inwards and the hydrophilic point outwards. This ensures water does not interfere. It's important to note, micelles form when there is a high concentration of surfactant present. This point is called critical micelle concentration. Surfactants, although going unnoticed, are very useful in our daily lives. They are even produced in our very own lung cells. They are able to penetrate the strong hydrogen bonds of water when absorbed and lower its surface tension, ultimately allowing soap, shampoo, detergent, or toothpaste to work. Water on its own is a very poor cleaning agent because its skin-like surface slides right by stains and has no effect. Surfactants are also involved in food production, and without them, mayonnaise and ice cream would not exist. Neither would Tide Pods, our favorite snack. There are four main types of surfactants used in the industry today, including anionic, non-ionic, cationic, and amphoteric. Anionic surfactants carry negative charged head groups, and it's the most commonly used type in modern cleaning products, accounting for 50% of the entire industrial production. You can find it in dishwashing liquids, shampoos, and laundry detergent. Non-ionic surfactants have neutral ends that better clean organic materials compared to anionic and account for 45% of the overall industrial production. They also act as wetting agents in coatings and food ingredients. Cationics have a positive charge on their end and will be found in antistatic products such as fabric softeners and disinfectants and can only be combined with non-ionic surfactants. Lastly, amphoteric surfactants have a dual charge which ultimately leads to a net charge of 0. This is known as zwitterionic. Interestingly, the type of charge amphoteric surfactants will take depends on the acidity of the solution, the pH. Acidic solutions will result in cationic, and alkaline solutions develop a negative charge. These are the most expensive type of surfactant and are used in cosmetics. Although very helpful to humans, the use of certain surfactants can be harmful to the environment and its organisms, especially in aquatic habitats. The detergent market on its own is worth $60 billion, where surfactant consumption worldwide was over 22 billion pounds by the year 2000, these mostly being products for home use. Many countries use different concentration of surfactants in their laundry cycles. Japan uses low concentrations, whereas Europe uses the latter. As mentioned earlier, the critical micelle concentration indicates the saturation of surfactant needed to effectively clean. This point is sometimes passed when producing cleaning agents, resulting in harmful excess surfactant molecules that do not further break surface tension. These synthetic chemical compounds allow surfactant toxicity to increase in aquatic life. According to the U.S. Environmental Protection Agency, surfactants break down into additional byproducts that are toxic. In freshwater areas, detergents will break down the protective mucus layer coating of a fish that serves against parasites and bacteria. The surfactants then reduce the surface tension of water, and aquatic life absorbs pesticides and other pollutants. Some can even disrupt the endocrine systems of these organisms, decreasing their breeding rates. However, the effect of these surfactants is controversial, as scientists continue to release different reports with opposite conclusions. Globally, several million tons of surfactants are used each year, piling billions of kilograms. Shockingly, a comprehensive survey of over 250 studies over several decades states that there is a minimal risk present in North American nature, since modern substances are produced to degrade rapidly after proper treatment. To the contrary, if surfactants are not fully treated, they can harm the skin, scales, shells, plant walls, and bacteria that act as a barricade to chemicals and pathogens. In rivers, oxygen is constantly consumed by decomposing plants. The presence of detergents continues to consume the leftover oxygen when they decompose. As a result, underwater organisms have inadequate amounts of oxygen, leading to asphyxiation. In Europe, the biodegradability is measured at 60% in 28 days under aerobic conditions. Some argue that this still leaves ample time for surfactant molecules to escape sewage plants and spread. Certain types will even attract to limestone and settle at the sedimentary bottom of rivers, making the process even more difficult. Over the time span of 2,000 years, the most significant changes of surfactant chemicals is the way society viewed them. The first fear of surfactants' potential danger began in 1980, when people began worrying that these compounds were being recycled into their drinking water. In Western Europe, all surfactant components of domestic detergents must be biodegradable. Other companies are attempting to solely make biodegradable cleaners that still get the job done. Microgreen Clean Biodegradable is a good example of an environmentally friendly and multi-purpose surface cleaner. Surfactants are an essential part of the world's economic and environmental impacts. Their special quality transforms slippery water molecules into less cohesive entities that will remove dirt from an array of surfaces. Acting as lubricant for shaving cream and aiders of our pulmonary airways, surfactants are versatile in their benefits. In 2010, millions of liters of surfactants helped disperse the oil spill in the Gulf of Mexico. Even today, they are the main source of a gigantic industry around the world. So, next time you do a load, remember the story of surfactants and who really does all the cleaning.